Hello, can you hear me?
Yes, hi, Azar. We're going to start in just a couple more minutes. Let's give everyone a minute or two to join.
Okay, so I just wondering if the screen has been shared.
Not
Everything
until
right?
I will take it down the next up next, and then you can share it then.
Ah, okay. For the video, you will play it, or shall I play it myself?
Yeah, I'll play your video when you're ready. Just let me know.
Thank you very much. Thank you. Just please feel free to mute the to mute it. I don't need the music. Thank you.
If you don't need the music, you can just play it yourself.
Okay. Yeah. Yes.
Go ahead and just play it
you.
yourself then. All right.
Okay.
It's 9 o'clock Pacific time, so we'll get started. As I said, up next, we have Dr. Azar. She's going to talk about 3D food printing and why. And with that, I'm going to hand it over to her. Azar, you've got the screen now.
Yes, thank you. Hello, everybody. My name is Azarmidokht Shirazi. I'm a research fellow at the University of Birmingham, and I'm working on 3D food printing. Here, it's a general, I have included my work, but I'm going to talk about a general overview on why we need 3D food printing from the viewpoint of economics. Please feel free to reach me by my Twitter at AZGHSH. Well, as it is customary these days, it's to open the talk with pandemic. And in these COVID days, especially during first lockdown, 3D printing has played a key role helping to keep medical staff and key workers safe and supplied them with, for example, those they need, the face visors, for example. 3D printers were used to make face visors and shields. Everything became local and decentralized out of necessity. But what happened to the food market? Well, all of us have faced it. During pandemic, the shelves were empty. Some food became scarce. Some restaurants and cafes were closed. The biggest risk for food security is not with food availability, but with consumers' access to the food. There are three types of food supply chains. Traditional models based around subsistence agriculture or short local supply chains, which account for approximately 10% of the food economy in Africa and South Asia. Modern food supply chains based around supermarkets and large processors, about 20%. And a large transitional sector, some 70% of the total, connecting rural producers to urban consumers through a web of labor-intensive small and medium-sized enterprises. Small-scale and decentralized food manufacturing models are emerging as ways to increase sustainability, flexibility, and resilience in food chains. 3D food printing is one of these small-scale and decentralized food manufacturing. As it is seen, the CAGR is quite high for 3D food printing. CAGR, compound annual growth rate is the rate of return that would be required for an investment to grow from its beginning balance to its ending balance, assuming the profits were reinvested at the end of each year of the investment's lifespan. Most food 3D printers use extrusion 3D printing technology, much like regular FDM printers. But instead of using plastic material, food 3D printers use paste-type ingredients. 3D food printing eliminates many of food manufacturing processes, for example, shaping and baking. Therefore, food producers can change their focus from food production to food ingredients production, which potentially less packaging and waste and loss. Additionally, 3D food printing can make food transport more feasible. Special food cartridges designed with 3D printing in mind will have far longer shelf lives as well as especially tailored nutritional profiles, which makes them especially suitable for use in developing regions. By implementing food 3D printing, food supply chain can be simplified to food ingredients producers, small and medium-sized companies that prepare and sell food cartridges, and customers who buy food cartridges and use them in their 3D food printers. These small businesses would need some simple design rules based on the paste rheology and physical and mechanical properties of the paste to prepare the material and fill the cartridges. This is something that we have done and reported in our paper already published in Food Hydrocolloids in 2019. I would suggest to see this paper to get more information about this. So far, we have seen how 3D food printing can create a local and decentralized food manufacturing and simplify the food supply chain. However, when it comes to food, these are not the only issues. We are facing other issues such as waste and loss reduction, recycling, sustainability, and so on. Around a third of food for human consumption is wasted. 30 to 40% of food production is lost, even before it reaches the main market. Misshapen, marked, discolored, or oddly sized fruit and vegetables that don't meet the standard of the marketplace are thrown away before even leaving the farm. Some food goes off when transported. However, food wasted by consumers is the biggest contribution to this problem. There were an estimated more than 70 million tons of household food waste in UK in 2015. Offcuts and foods past their use-by dates are binned by both retailers and by us at home. Cooked, uneaten food is binned. The amount of avoidable household food waste in 2015 was more than 4 million tons in UK. How 3D food printing can intervene to decrease food waste. Here is an example. The company of printing food used food waste as the ink for 3D food printers. The necessary ingredients like bread, fruits, and vegetables from residual food flows are blended and combined to produce a puree, which will later be seasoned by herbs and spices. The puree is then 3D printed, and these prints are baked and dehydrated so that the resulting product is nicely crunchy and long durable. The point is that they turn the food waste into the food, so they give it a second life. However, it is also possible to turn the food waste to something else. I have brought two companies here side by side. Cubits, the picture on the right of the screen, makes frames from 10 different waste materials. For example, potatoes, sheep's wool, corn husks, chopping boards, plastic packaging, human hair, mushrooms, yogurt pots, CDs, and cornstarch. The point is that they do not 3D print their frames. All of them are crafted by hands. Rolf, the other company on the left of the screen, Rolf makes glass frames out of castor beans paste. The interesting point is that they 3D print their glasses. So it is possible, or we encourage Cubits to think to 3D printing. Here I have a video. This is also another example. This Italian company has developed an orange juice bar that turns the waste fruit peel into 3D printed bioplastic cups to drink the content from, as an example of the circular economy in practice. Another issue. The world is facing an environmental crisis and natural resources are depleting fast. Reducing beef production would result in a huge reduction in CO2 emissions and far less clearance of wide countryside for grazing land. 3D printing is certainly a disruptive force across all industries, and meat industry is no different. 3D food printing is almost a zero waste production because only the food that is printed will be consumed. Furthermore, due to its flexible nature, 3D food printing will promote the incorporation of low-carbon food ingredients, for example, algae, insects, etc., into pioneering edible objects. 3D printing seafood and meat from cells or plant protein resources with similar taste and texture to the original leads to the development of foods at reduced environmental impact and improved quality. Israeli firm Redefined Meat is 3D printing meat. The ink is made out of plant-based ingredients. It contains proteins from legumes and grains to create the muscle texture of the alternative meat. It also contains fat from the plants to mimic the beef fat, and natural flavors and colors to mimic the blood factor in meat and its juiciness. One of the main advantages of 3D food printing is for food customization. I would invite you to read this paper of ours. It's a review paper on 3D food printing, and it's open access. We have comprehensively discussed the applications of 3D food printing. 3D food printing permits the creation of new geometries and offers original production ideas in food and manufacturing with superior control over composition structure, texture, and taste. 3D food printing could provide a solution to reconfigure a specialized supply chain intended to assist people with special dietary requirements. By combining the creation of uniquely textured foods with superior nutritional value or ingredients combinations during printing, or using multi-printing process that uses several ingredients, 3D food printing can lead to personalizing, customizing food both in terms of sensory and nutritional profiles for special consumer groups, for example, young people, elderly, pregnant women, athletes. Alleviating issues surrounding foods on the go to astronauts and military personnel, or food as pharma in hospitals or veterinary clinic for pets. The only necessary thing to make the food will be food cartridges, food 3D printers, and energy. Here I have introduced 3 examples. This is a company that makes the ornaments, Christmas ornaments, from sugar. This is another company that makes the extrusion that I already showed you, their extrusion for bakeries. And we had some commercial chocolates made by Cadbury, already 3D printed. This is a new project that I'm working on. It's to introduce a new range of diet food. We studied the British biscuit, and we found that despite having the same calorie and the same nutritional values, the force that needs to be that are used for chewing them is different. It's already proved that mastication has a very high impact on the diet. So we are deciding to use 3D printing to create different texture for and create with the same nutritional values, with the same calorie, but to increase the mastication, the chewing time, so that we can develop a new range of diet food. This project is going on, and we are seeking collaboration. Please feel free to contact me if you would like to be involved. At the end, I think that it is interesting and convenient to occasionally send the dinner menu via your cell phone to 3D food printer at home before leaving work. And when we arrive, a nice dinner is already printed and ready. It is pleasant to indulge in the Star Wars life. Thank you very much. If there is any question, I will be happy to answer.
Thanks, Azar. That was really great. That was really interesting. I had no idea, actually. I knew about a few of those things, but I had no idea that there were so many different types of companies out there doing food printing. I did mention in the chat that actually the founder of Sugar Lab is moderating the panel tomorrow in this track on entrepreneurship. So you might want to catch that as well, Megan Bozeman.
Sure, that's interesting.
Does anyone have any questions? All right. Well, if you think of anything, you can always find Azar, I believe, on LinkedIn. Connect with her there and ask her some questions. If you're around later in the networking session, you can probably find her then.
I am. Thank you. Thank you very much. Thank you.
Have a very much.
Thank you.
Have a good rest of your day. All right. So up next, we have Stephanie Benight, Dr. Stephanie Benight. She is the president and principal scientist at Tactile Materials Solutions. She's going to be talking about photopolymers and pretty much everything around photopolymers in production, the technology, OEMs, materials, sustainability, and applications. So stick around for that. If you want to return, we have about 10 minutes until she's going to start. So if you want to return to the main stage, go ahead and type that URL that's at the very bottom of the screen into your browser. Otherwise, we'll see you here in 10 minutes. Thanks a lot.